Often in many circuits, we have to convert the circuit resistance into equivalent resistance, maybe in Thevenin circuits, in Norton circuits. Many times we find out that the circuit is difficult to solve for the equivalent resistance because there are certain patterns that are present, like star and delta. If we know how to convert star connection into delta connection and vice versa, delta into star, it becomes easy to solve for equivalence resistance. And hence, we need to know how to convert these into each other. Now, we know how star looks like. This is the star connection and this is the delta connection. For the convenience, we have named the resistance as RA, RB and RC, where each branch is connected at point A, B and C. The branch that is connected in delta between A and B is named as R1, between B and C is R3, and between A and C is R2. It is irrespective of how the points are connected here. But this RA, RB, RC is in convention with the points connected. In the blue, we see the delta connection, and in green, we assume that there is its equivalent star connection. Now we are going to see how to convert these resistances into each other, these connections into each other. There are specific formulas, and I will tell you a trick that I use to know or to remember these formulas. So here we have delta to star conversion. Let me just write star here. Delta to star conversion. So now on the right hand side you see some formulas for RA into, or maybe we have given the delta connection, that is R1, R2 and R3, and we need to convert this R1, R2 and R3 as RA, RB and RC. There are particular proofs of converting these into each other which are mathematical, and we are not going into those proofs, but I am going to tell you the formula and the trick to remember. Now we have RA, RB and RC, alright, to be found. We know that delta into star. So what I use is delta is having more letters and star is having less letters. So basically when converting from delta to star, the ultimate resistance is going to reduce. Alright. Now the formula is RA is equal to R1 R2 divided by R1 plus R2 plus R. Alright. So this is RA. So the adjacent resistance is R1 into R2 divided by R1 plus R2 plus R3. Similarly for RC, we will take adjacent resistances R3 R2 divided by R1 plus R2 plus R3. The denominator is same everywhere, alright. But this analogy, the delta is having more letters and star is having less letters, so resistance is going to reduce, which is verified if we take R1, R2 and R3 to be same, all equal. So let us say all are R. So RA, if RA is also, so RA is basically converted into R square divided by 3R, which gives you R upon 3. So if original resistance of each delta branch was R, the star connected network gives you R by 3, which is lesser resistance. Okay. So you will know this analogy when you see the star to delta connection, because there are more 3 formulas, and people often do get confused between these 2 formulas, which to apply for which one. So when the resistance is being reduced, you know that is delta to star connection, right? So assuming all resistance is equal, you get 1/3 of the original resistance from delta to star. So this is the resistance for RA, RB and RC. Only numerators change, and numerators are nothing but the multiplication of adjacent resistances of each other. Let us see how to convert star into delta. So we are given star, that means in the green that is given, and we have to find out the blue ones. Alright. Now again, these are the formulas for R1. R1 is equal to what? All the resistances multiplications addition. RA into RB, RA into RC and RB into RC. So each resistance multiplied by each other and their addition. RA RB, RARC and RBRC divided by the resistance which is opposite to this particular R1. So if we have to find out R1, denominator will be RC. Similarly, let us find out for R2. The numerator will be same, RARB, RARC and RBRC divided by RB. So this is how you can find out. Now there are these two different formulas. Now here we are converting from star to delta. Alright. There are 4 letters, there are 5 letters, so resistance is going to increase. So assume each resistance is same, RA, RB, RC is equal to R. So what we get here is equal to 3R square divided by R, which gives you 3R. So from going from star to delta, ultimately the resistance increases. R1 gives you 3R, while each resistance was R. So these are the basic formulas. Let us take one simple example to develop the understanding more for star to delta conversion. So here we have given one connection. If you look closely, this is nothing but a delta connection, and now we have to use the delta to star connection. Now again delta to star. Alright. So we have to use the formula. Which formula we are going to use? The one which reduces the resistance. Which of the formulas reduces the resistance? The adjacent resistances multiplication, which is nothing but RA, or let us say 12 into 14, let us name them as R1, R2 and R3. Okay, so we'll get R1, R2 divided by R1 plus R2 plus R3. Alright, so basically for RA, we will use 12 into 13 divided by 12 plus 13 plus 14. Alright, so this will give us RA, RB and RC. So we have successfully used the formula which is going to reduce the ultimate resistance. RA is found out to be, this is RA, found out to be 4 ohms. RB is found out to be 4.66 and RC is found to be 4.3. As you can see, all these resistance values are lesser than the original values. Alright. So delta to star reduces the resistances, and particular that formula to be used. I hope you have understood how to convert delta to star and star to delta. Please remember these formulas, because these formulas are very important and you will remember them with extensive practice. I hope you have understood the trick also. I will meet you again whenever you call me back. Thank you so much.